Well, good afternoon, everyone. Welcome to day 6 of section 7.5 as we review and get ready for a test. I just wanted to go through a couple of these review questions with you. Your homework for today, which will be Wednesday for my odd number classes and Thursday for my even number classes, will be worksheet number 6. Finish up the packet that you have. You've already seen this once before, so you have seen these formulas. So these formulas are all interest formulas, growth and decay. Remember that, and I know that we don't see them here, but I hope that you remember that this one is continuous interest. All right, so that means you are earning interest continuously. The one in the middle, so this is the one we called PERT, P-E-R-T. That's this little piece right here. The formula in the middle, so this one is our compound formula. So meaning that you are compounded annually, semi-annually, quarterly, daily, yearly, anything besides continuous. Continuous means every second of every minute of every hour of every day. So this is your compound interest formula. And then the other two, this one is a growth, meaning you are earning money on a daily basis. Sorry about that. And then this one is a decay, meaning you are losing money on a daily basis. So if we have something that depreciates, we'll use this one. If we have something that appreciates, we'll use this one. So this one's a growth and this one is decay. And I thought I'd just do one of these just to remind you how we were doing them before we were so abruptly sent out of school. So I've pulled up the calculator for us. Let me clear all of that off. And let me just do number 1 for you. So this is your homework, and you know I like to do your homework a lot of times. So hopefully you're paying attention to this and that you are able to do these particular problems, the interest problems. You are more than welcome to use your notes when you take this test or this quiz that we're going to take on Monday and Tuesday of next week. So you can have the formulas with you. You can use these notes, whatever you need. You will have one chance to retake it in Alex, so just be ready. So number 1 says Katie deposits $1,500 in an account that pays 16% interest. Okay, well, I wish I could find that. If Katie wants to double her money, how long would it take for the balance to double if the interest is compounded continuously? Well, that tells me right away that the formula I need to use is this one. Amount is principal, E raised to the RT. All right, well, here's what happens. Her principal, the amount of money that she starts with, is $1,500. E is a set amount. The interest rate is 16%, 0.16. It's a 2-digit rate. 16 is 2 digits, so I do not need the 0 in front of it. But what I don't know is the time. So I'm going to put that in as time. Now, what I want to know is it asks me to double her money. Well, if she started at $1,500, then that means she's going to end with $3,000. That's what 1,500 times 2 is, or doubling her money. So here's what I need to solve. And in order for me to solve it, the first thing I need to do is to get rid of the 1,500. So I'm going to divide both sides by 1,500. And then I'm going to write it up here. So 1,500 into 3,000 will take this to 2 over 1, or it'll just be 2 is equal to E raised to the 0.16t. Okay, now you have to think back to what we've done for the first part of this unit of review. As anytime we had an exponential, we always changed it back to a logarithm. And anytime we had a logarithm, we always changed it to an exponential. So that means this is going to drop down, this is going to move over, and whatever was on the other side is going to switch places. Okay, so what that means is, and if that confuses you, you may want to write it a little differently. So this is what I mean. It's e to the 0.16t is equal to 2. So this goes down, this goes over, 2 comes back. Now here's what I have. I have ln base e of 2 is now equal to 0.16t. All right, this is where the calculator comes out. So I'm going to pull out the calculator and I'm going to type in ln of 2. That's it, ln of 2. I'm going to find out what that value is. It says to round this to the nearest hundredth. So tenth, hundredth means 2 decimal places. So when I look at this, I see that it is 0.69 and the digit behind it is a 3. So therefore, I don't round it up. I just cut it off right there. So I have 0.69 as my value of the natural log of 2 equals 0.16t. And then in order to solve it, I'm just going to divide by 0.16. So I'm going to take this 0.69. I'm going to type in a 0.69, and then I'm going to divide it by 0.16. And when I hit enter, it's going to tell me how long. Now, it looks like I need 4.31 years or 4.3 years. I'm going to say, wow, that's not very long. So I'm going to take my time and say that it's 4.3 years. Now, I'm not real satisfied with that, so I'm going to check it. So I'm going to go back to my original equation. This one that says I needed 1500 e to the 0.16t, and I'm actually going to type that in, 1500. I've got an extra 0 there, so I'm going to put the e, 1500 e, raised to the 0.16 times 4.3, and I hope, it looks like I have 43, 4.3. I'm going to hope that gets me close to 3,000 or I have made a mistake. And hey, it does. 2984.59. Now, the reason that it's not quite 3,000 is because I rounded. So anytime I use rounding, we get what's called rounding error. So this isn't an exact amount, but according to the rounding rules that they've asked me to do, rounding to the hundredth, that's 2 decimal places. Then I probably should take my time and raise it to the 4.31. So let me add that in there. Let me try that again. Let's put that entry in, and let's go back up here and change this to 4.31. Let's see if we can change that, see if that gets me closer to, yeah, it makes me about $10 away at that point. So at any rate, that's the reason why it's not exactly $3,000. Okay, so we're going to have to remember a couple of those interest formulas, and then we're going to ask you to be able to solve exponential and logarithmic. Okay, those are 2 very different kind of questions, and if you have 2 of these, so these are both exponentials, and if you have exponentials, you want to change them to logarithmics. But when I look at these, I see this one has a 2 and this one has a 16. And so unless those 2 numbers match, we are wasting our time. So the first thing that I remember that I need to do is make this the same as the 2. So can I rewrite 16 so that it has a base of 2? And indeed I can. If I take 2 and I raise it to the 2 times 2 times 2 times 2. 2 times 2 is 4. Times 2 is 8, and times 2 is 16. So 2 times 2, 4, 6, and 8. So if I do that, then I want to raise this to the 4th power. Now, that's just rewriting the 16. That's the only thing I've done. And now it is also raised to the x minus 2. And that's equal to the 2 to the x plus 10. Now, remember when you have a power to a power, and let me pull out a different color here. When I have a power to a power like these 2 are, I have to multiply those. So that means in this case, I'm going to distribute it. So let me go back to red. I have 2 to the 4 times x minus 2 is equal to 2 to the x plus 10. Well, when the bases are the same, I can just take your exponents and set the exponents equal to each other, because that's the only thing I'm doing is comparing. So I'm going to compare these two. I'm going to do this in purple. So what I have is an x plus 10 is equal to, and I'm going to distribute these two, 4x minus 8. And then it becomes a very simple Algebra 1 question. I'm going to subtract the x, so that's going to leave me 3x, and then I'm going to add the 8. And when I add the 8, I get 10 plus 8 is 18. And then I'm going to divide both sides by 3, and my x value is going to be equal to 6. Now, I need to check those. So remember, all of these, you should have the time to check every single one of them. So I'm going to clear this off. I'm going to go back and I'm going to take 2 and I'm going to raise it to the x plus 10, or the 6 plus 10 power. Right? I didn't even want to add 6 plus 10. So I got 65,536. And then I just need to check the other side. I need to make sure that these two values are the same. So I have 16, and this time I want to raise it to the x minus 2, which is a 6, not a 3, a 6 minus 2. And I get the exact same thing. So therefore, the value of x is equal to 6. Perfect. All right, I'm going to leave the other one for you, and I'm going to leave some of the rest of these to you as well. I'm going to do one of these logarithmic equations here at the bottom. So if I choose this one, number 8, remember that your logarithm that you have, let's pick a different color. Let's go back to red. All right, so if this logarithm I have has to have a base, so it's log base e. So your natural logs, your ln, are base e of x is equal to 4. And so in order for me to solve a logarithmic equation, I need to change it to exponential. So to do that, bring the base up, give this to its exponent, and switch this to the other side. So what I actually have is e to the 4th is equal to x. Now that's fabulous because I think these are awesome. I'm going to clear this off, and then I'm going to take the e, second letter e. I'm going to raise it to the 4th power, and my solution, it's going to ask me to round it to the 100th. So the 10th hundredth is 2 decimal places. So if I look at this digit, the 2 place is a 9. So I look at the one behind it, and it's an 8. So since that's 5 or above, this has to go up. Well, since it's 59, it has to round to 60. So what I'm going to round this to is 2, and let me pull it back up so you can see it one more time, is 54.60. So I'm going to say that this value is 54.0 is the value for x. All right. Now, I'm going to check this. So I'm going to go back and take the ln. And instead of me doing 54.60, I'm going to do the exact value that I got, and it's going to tell me it's 4. If I go back to the ln and I put in 54.60, it's going to get me close to 4, but do you see it's a little bit over? And the only reason it is like that is because we have rounded. So we talked about those rounding errors. Here it is again. So that's why banks are very, very particular about what they round their values to. And they will not round anything except to the exact monetary amount. Otherwise, they're losing money all the time. All right. When you get to the last page, you're going to see some more logarithmic equations that are going to require you to know those properties. There's 3 properties of logarithms. I'm going to do number 11 for you because with this one, there is no property. You just have to compare those 2 pieces. But with number 11, this 3 that's multiplied in the beginning of that equation tells me that if it's a multiplied by a logarithm, that it had to go back to being a power. So we can put that back, Or in this case, let me pick an eraser out here. Or I can go ahead, and in this case, I should be able to just divide that 3 away. It won't hurt anything to divide the 3 away, and I'm left with the log base 2 of 8x is equal to 5. Now, I have a logarithmic equation, and in order to solve a logarithmic, I have to change it to an exponential. So here we go. We're going to change it from a logarithmic to an exponential. I'm going to bring the base up, give 5 to be its exponent, and move the 8x to the other side. So what I have is 2 to the 5th is equal to 8x. I'm going to pull up my calculator again, if I can. There we go. I'm going to clear off what's on here, and I'm going to take 2 and raise it to the 5th power. And on the left-hand side now, I have a 32 is equal to 8x, and it's a nice one. So when I solve it, I'm going to divide both sides by 8, and my value for x then is going to be equal to 4. Don't forget that I need to check all of your solutions. I round them to the nearest thousandth. So in this case, they wanted them raised to 1,000th, which is, if you look at your decimal places, it's tenths, hundredths, thousandths. So if I'm looking for the 1,000th place, it means I want 3 decimal places. Okay, don't forget that. Well, let's check this. So what I had was 3, and I'm going to put this value of 4 right here. So it'll be 3 times the log. Oh, but don't forget, I've got to change the base. So I'll go to my math. I'll go down until I can find, oh, I forgot to put the 3 in. So let's put the 3 in and then go to the math, change a base. And there it is. We're going to change the base to a 2. And then inside the parentheses, I want it to be 8 times 4. Now, if I don't want to multiply 8 times 4, just put 8 times 4 in there. And there you go. We've checked it. And my check value does work. And all you have to do to show me you've checked it is just write it in there. Log base 2 of 32 equals 15. And then you are free to check it on your calculator. All right. The rest of these, you can practice these. If you need some more help, you know where you can find me. I am more than happy to do your homework. I love math. You guys know that. So you guys let me know what you need, when you need it. I am more than happy to help out at any time. So make an appointment with me if you need it. Submit your homework, upload it into a Google Classroom, and we will continue learning. I miss you guys, but hey, we're going to do what we need to do. All right, have a great day, everyone, and I will see you soon, I hope. Bye-bye. Stay safe.